Hello everyone, today in this video we'll be discussing the fourth module of maths third semester. So in this module we have 6 topics, each of them has a formula related to it and some types of questions. We'll be discussing each of them, all of them are from the previous year question papers and important from the exam point of view. And before starting, make sure you hit the like button and subscribe to my channel, that helps me make more videos like this. And if you watch this video till the end, you can easily score more than 80% marks. So without wasting any more time, let's get started. The first one is central limit theorem. Okay, so let's have a look what is central limit theorem. So these are the terms used. If you use x bar, that means it is the mean of the random sample. Okay, so from a population of the data, we are taking a small sample of it. The sample's mean value is denoted by x bar. N is the size of sample, how many values you have taken in the sample, and nu is the mean of the population, means the whole population's mean value. Okay, that is denoted by the nu, and sigma square is the variance of the population. Now the formula is that you have to find the z value. It is given by x bar minus nu divided by sigma minus root of n. Okay, so let's get started with the previous questions. The first one is, an electrical firm manufactures light bulbs that have a length of life that is approximately normally distributed with a mean equal to 800 hours. Okay, so they are giving us the mean value of the population. Okay, because they haven't given the sample random here, means the random sample is not given to us, it's directly given as 800 hours. So this is the mean of the population, which is the new value, and a standard deviation of 40 hours. So sigma value is given to us as 40. Find the probability that the random sample of 16 bulbs will have a life of less than 775 hours. Okay, so our random sample is 16, means n value is 16, and the average life is less than 775 hours. The average life means the value of x bar they have given us. Okay, so I will note down all of these things: new value, sigma, n value, and x bar value. We'll substitute those values here. But wait, what they have asked here, will have an average life of less than 775. So we have to calculate the probability of x bar less than 775. Okay, so 775 one, we will substitute here the values here, and we'll get a value which is minus 2.5. Now you have to calculate the probability of z value less than minus 2.5. So if you draw a graph here, the 800 will be the average, which will be in the middle, 775 is here. We have to calculate how much is this probability. Okay, so this probability can be given as the area from minus infinity to minus 2.5. This is 2.5 here. Okay, and this is minus infinity. So from minus infinity to minus 2.5, what is the area? That is our answer. So this area will be equal to the area which is from here 2.5 to infinity, right? Can take it like this also. Now this value, how will calculate? The area of infinity minus area of 2.5. A of 2.5, the A value table you have to refer. Okay, A of 2.5, by referring to the A table, you will be getting the value. Substitute that and you'll get an answer 0.0062. That is the probability which you are trying to find out. Okay, let's have a look at another similar question. An unknown distribution has a mean of 90. So the new value is given 90, the population's value. Standard deviation of 15. So standard deviation sigma, 15 value is given. A sample size of 80, n is equal to 80, is drawn randomly from a population. Find the probability that the sum of 80 values is more than 7400. Now the sum they have given 7400 and the n value is 80. So in order to calculate x bar, which is the mean of the random sample, they have taken 80 things in the sample, right? So 80 I'll substitute here, and the sum is 7400. So 92.5 is the mean. Now more than 7500 means I have to calculate the probability of more than 92.5. Got my point? And these values they have given here, I have to calculate it more than 92.5. Substitute the values here and you'll get an answer 0.0681. Okay, that is the this is similarly how we did in the previous question. Similarly here also we will be doing the same thing. Okay, you have to refer the A table and calculate as follows. Okay, moving on, certain tube manufactured by a company have a mean life of 800 hours. This is what? This is the new value. SD of 600 hours. This is the sigma value. Find the probability that the random sample of 16 tubes, n value 16, taken from a group with a mean lifetime between 790 and 810 hours. Now x bar value is between 790 and 810. Now we have to calculate in between value. Okay, and here less than this much, more than this much, and between this much. Now if you get to know how to calculate for one, you can calculate for between, for less than, for more than, for equal to, anything you can calculate. Same formula, everything. Just note down the things which I have given: 800 here and 60 and 16. In between means For 790 you will be writing x bar as 790 and the rest of the things substitute from here, and less than this value and less than 810, then the values will be substituted from here. Now after calculating you'll be getting a range here, and based on this range what you can see is 0.67 to 0.67 minus 0.67 to 0.67. See here, if I draw the graph like this, it will be minus 0.67 and plus 0.67. Now if I divide it into half, this will be equal to this one, right? So I can take 2 times of this one for the whole area, right? 2 times of this one, so 2 times of 0.67 is equal to this whole range. So the value will be given like this. This you will have to refer the table of a table and calculate it accordingly. Okay, similarly for the remaining three also you'll be doing the same thing, just instead of in between you have to calculate whatever they have given. If they have given less than, just take less than and don't take this part here. If they have given greater than, just take this one, don't take greater than, and so on. Okay, moving on to the next topic, which is students t-test. Okay, so some formulas are given here, you can go through it. So we'll just get started with the question and see how the formula applies. A random sample of 10 boys have the following IQ. Okay, so 10 boys sample is given to us, n value is 10 here, and the IQs are given for the 10 students. Okay, now do the data support the assumption of a population mean of 100 IQ? Now if they give a question of like this, do the data support, that type of question is students t-test. Okay, now the population mean is 100, new value is given as 100, the population's mean. IQ is also given to us. We can calculate the IQ here. The mean value of the sample, which will be 97.2 here. Add up all of these divided by 10, you'll be getting this value. Now, for finding out in students t-test, you have to do the following calculation. See here. After you calculated the x bar value, you will write the x values here first in the top column, and the down column will be nothing but the particular x value minus the mean value. What is mean value? 97.2. So to get this answer, what you will do? 70 minus 97.2 whole square. 70 minus 97.2 whole square. For this, what you will do? 120 minus 97.2 whole square. Like that, you will keep on doing for all of them. Then find out the sum of all of the top row values you will calculate here, and sum of the bottom row values for all of this you will calculate here and keep. Okay, now after calculating these two, apply this formula. This value which we got here, apply this formula here. I square we will be calculating variance, and n minus 1, n is 10, 10 minus 1 is 9. Calculate the value, will get an s square value. Take the square root of it, you will get the s value. Now after you have found out the s value, next step is to find out the t value. The t formula is this one. Substitute whatever we have here. We have the x bar value, new value is given in the question, and this we calculated here. N value is 10. Substitute, you will get an answer minus 0.6203. Now the t value of 0.05, either they will give in the question or you will be given with a book in which the t table will be there, right? You have to refer either of them and get the t value of 0.05. So you'll get here 2.262. Now you have to compare if the answer which you have got is less than this or not. Always remember, if the answer you got is less, then we accept the hypothesis. If the answer is more, we reject the hypothesis. In this case, answer is less, therefore we accept the hypothesis. Okay, this is how you calculate the students t-test. Formula is same, means the steps are same for all the questions. Find out the mean value, and by using this table find out the sum of this term, find out the s value, substitute in the t equation and find out the t value, compare it with the t from the tabulated value of 0.05 from the table, and you'll be getting the value. If it is less than that, it is accepted. If it is not, it is rejected. Okay, going to the next topic, we have the confidence limits. Okay, so confidence limits will be given with equation. Means the question will be given wherein we have to calculate the confidence limits. They will specifically mention the question, so don't worry about that. Now there are two types. Okay, one is large sample, one is small sample. Now what is a large sample? The value is greater than 30. Small sample less than 30. Okay, now if it is large sample, we'll take z alpha. If it's small sample, we'll take t alpha. Now z alpha and t alpha can be substituted based on what is the percentage of confidence limit you want to calculate. If it is 95%, we'll calculate, substitute the value 1.96 here and here. If it is 99%, we'll substitute 2.58 here and here. Okay, these are the same terms from the previous question. Now let's get started with the question. A random sample size of 25, n is 25. If n is 25, it is less than 30, means we'll take a small sample which is t alpha. From a normal distribution, sigma square is given to us. For yields a sample mean of x bar is given. Obtain a 99% confidence, we'll substitute 2.58. Okay, for the interval nu we have to calculate the confidence limit for the interval. See, interval they gave means See, interval they give means that is the confidence limit type of question. Okay. Now see, they have given us the mean. Just write the mean here. Population variance is also given. The sigma square value. Now sample size n is 25. 99% means alpha value will be 0.01%. Means 1%, which is 0.01. Okay. So alpha value will always be in the decimal. Now for this level, the value of table t is, you have to calculate. See, if it is large sample, refer the z table and find out the value. If it is a small sample, refer the t table and find out this value. It is 2.797. Usually they will give in the question. If they don't give, you have to refer to that table, t table or z table. Okay. Now confidence interval, the formula is like this. This is one term. Okay, this first term, this is second term. Here what we are doing, first we are calculating a value t alpha s by n, t alpha s by root n. This you will be adding with x bar minus this value, x bar plus this value. Okay, like that. That is how we obtain the confidence limit. Now these values we have, t alpha value is 2.797 from the table, and s value is 2, and the square root of n is 25, so square root of n is 5. And what is the s is given to us here. S is the square root of the variance. The standard deviation is nothing but the square root of variance. So square root of 4 is equal to 2. Okay, square root of 4. So S value substitute here. Find out the answer. You'll get limit here. This is the lower end and this is the upper end. So this is the confidence limit for 99%. Okay. Let's have a look at a similar question. The heights of random sample of 50 college students show a mean of 174. Okay, so n value is 50 and 174 is the x bar value. Samples is a mean. Standard deviation is given as 6.9. So this is equal to 6.9. Construct a 98%. So alpha is equal to 0.02 and confidence interval for the mean height of all college students. Now see, the number is 50 here, so it is obviously it is larger than 30, which is why we have to calculate the z alpha value. We have to refer the z table, and the confidence interval is given, so this is a confidence interval question. Okay, now see, and we have the 50, that's why we have to take the z value. X bar is given 174.5 and s value is 6.9. So now we have to use the z distribution. For 98%, alpha will be 0.02. Now, at this level, the table value of z table value will refer the table, and C, we will get the value as 2.326. Now, the confidence interval is given similar to the previous one, wherein we will be adding the mean value minus z into, this is the s value, which is the standard deviation divided by square root of n. In the previous one, we had s by square root of n. S and sigma is both the same. Okay, this is for the large sample we denote by sigma, small sample we denote by s. Okay, substitute these values, all the values are given to us, so just substituting we'll get the answer here. Okay, so this is the confidence limit for 98%. Now moving on to the next topic, we have test for significance of difference between the sample means. Okay, here we will be using this formula. Two samples will be given to us, x sample, y sample. Calculate the means here and the number of terms in the first sample and number of terms in the second sample, and multiplied by s value. How we'll calculate? S square is given as this formula. So first we'll calculate s square, then we'll calculate s, and after that we'll substitute these values to calculate the t value. Now also a square, based on what values they have given. If they have given the values of x and y values, we have to calculate it using this formula. If they are given directly s1 and s2 values for x and y, you have to use this formula. For both of these questions, I will discuss how to do that. Okay, so firstly we'll discuss this type of question. Now see, below are the given the gain in the weights of cows fed on two diets A and B. So there were n number of cows, and for those cows they gave diet A, and for some cows they gave diet B. Now, based on the diet A and diet B given, the gain in weight happened. So, diet A, this was the gain in happened, this much kg the cows had gained in the weight, and diet B, this much kgs the cows had gained in the weight. Okay. Now, the number can be different here. This is N1, this is N2. Okay. Now, since they have given the numbers here, we have to use this formula. Okay. Now, what we have to calculate first? Now, the question is test if the two diets differ significantly. If they ask this type of question, if it is differing significantly or not, that is the type of question where we will be applying this formula. Test of significance of difference. This term will be there in the question. Okay, and two samples will be given. That's how you know this is the type of the question. Now, first set up a null and alternate hypothesis. Null hypothesis will be H naught, which is there is no difference. First, we'll assume there is no difference. Okay, and then we'll proceed. Now, what is N1 value? 12. and 2 value is 15. How we will calculate n1 and n2 value? Count how many values they have given in this one and count how many values they have given in this one. Here they have given 12 values and here they have given 15 values. So n1 is 12 and 2 is 15. Now the summation of x1 336, summation of x2 450. Okay, so add up all these values and add up all these values. This is summation of x1, summation of x2. Okay, and after that calculate these values. X1 minus x bar square. Okay, x bar, how will calculate? How will calculate the mean value? I have given you n number of values here. Calculate the mean. How do you do that? Add up all of these, right? How many are there, right? So adding up all of these, we got 336 divided by how many values are there? 12. This is nothing but x bar value, x1 bar. Similarly calculate x2 bar also. After you calculated x1 bar and x2 bar, then what you have to do, subtract x1 minus x1 bar for all of them. Okay, so x1 bar we have got as we haven't written here x1 bar. So whatever value you got as the mean value, suppose that you got 56. Okay, x1 bar suppose it is 56. Okay, so here it is written 28. X1 bar is 28 and x2 bar is 30. Now 28 and 30. Okay, let's consider x1 bar first. 28, how you will calculate this value? Okay, now see, 28 is here, right? X1 bar, what you have to do is subtract 28 from all of this. 28 minus 25, 28 minus 32, 28 minus 30, and so on till this point. Whatever answers you have got, right? Those answers you have to square individually and add them. For example, 28 minus 25, what is 28 minus 25? 3. 3. And here 28 minus 32, 4. 28 minus 30, 2. All these 3, 4, 2, like that values I'm getting, right? What you have to do, 3 square plus 4 square plus 2 square plus whatever we get, 6 square plus 10 square, and so on. Like that all the squares you have to calculate. That sum is written here, 380. Like that, do this same thing for here also. Okay, after you do these two things, you have got the terms which are required for calculating. Now the formula which we'll be using is this formula. Okay, the first formula which I showed you, that formula we'll be using. Okay, this is the same formula which I showed you here. Let's just have a look at it. This is the formula which you'll be using. Okay, now you have got this value and you have got this value also, right? Now after you have got this value, just substitute those values. Okay, substituting, this value is 380 and this value is 1410. Okay, 380 and 1410, 380 1410. After that substitute n1 and n2 also, 12 and 15 minus 2. Calculate a square, take the square root, you will get a value which is okay. Square root is not required, a square only will substitute here. So after that because see, if a square you substitute here, you will take the root, s will come out. Okay, you got my point. Either you can calculate root separately and take s out, or you can write here only a square and calculate, then take the square root. Both are the same things. Okay, so calculate these values, you'll get an answer, and take the modulus here. After you take the modulus, you'll get a value, final value, t value. Now after getting t value, what you have to do? Now see, they had given us for 5% LOS, 5% uh, limit of significance. Okay, for that what we have to do is, you see, they have not given anything here. So in case they don't give anything, we'll assume 5% limit of significance. Okay, so for 5% limit of significance, you have to see the table and get the value, the tabulated value of t of 0.05. This value will be equal to 25, not 25, it will be sorry, not here. Okay, see, um, okay, 2.060 is the value which you get when you refer to the table t of 0.05. Okay, this value at the degree of freedom 25, df is equal to 25 and t 0.05. When you refer these two values together in the table, you will get the value 2.060. Okay, this value we have to compare with what value we have got. 0.61 you have got, this is the value which uh, we have checked from the table. Now if you compare these two values, which is smaller? This is smaller, right? If this is smaller, we'll accept the hypothesis. Okay, always what answer we get, if it is smaller, we will accept that hypothesis. Okay, so we accept the following hypothesis, and therefore we conclude that there is no significant difference in their increase in the weight. Okay, let's have a look at a similar question which is of the second type of formula. So in the second type of formula, the question will be as follows. Sample of two electric light bulbs were tested for the length of life and the following data were obtained. Here two types are given, so obviously we have to calculate the significant difference. They have asked here difference is sufficient or not. Okay, now see. N1 is 8, N2 is 7, X1 bar is 1234, X2 bar is 1036, S1, S2 value they give. Okay, they'll give you the sample standard deviation value. If they give, you have to go with the second formula. What is the second formula? First, write the setup null hypothesis, which is there is no significant difference. Okay, now X1 bar, X2 bar, S1, S2, substitute using this formula. After you find out the value of capital S and substitute the value of capital S query here. Here so we'll get an answer. That answer is the t value. Now t is 9.37, and here what they have given, here they have not given anything, so we'll consider 5% LOS. And after considering 5% LOS, the value of t at 0.05. Okay, t at 0.05, what is the value you get from the table? That value you will compare it with the value which you have got. Okay, so answer you have got is 9.37, and the value in the table is it will be less than 9.37 only. So if you see the table of 0.05, it will be less than 9.37. It will be 0.026, like that something it will be. Okay, so since this value is greater which you have got, we will reject the hypothesis. Okay, so this was about the significant difference type of questions. Moving on to the next topic, which is chi-square test. Okay, so this is the chi-square formula. Here we will be calculating observed and expected. Okay, the frequencies observed and expected, we'll calculate these ones and then calculate the whole thing, and we'll get a value here. Based on this value, we will see if the uh, fitness is good or not. Okay, we'll try to calculate here the goodness of it. Okay, so you'll understand what it means. So let's have a look at the question. In an experiment of pea breeding, the following frequencies of the seeds were obtained. Okay, so how many seeds are given? Round yellow, wrinkled yellow, round green, wrinkled green. So four types of seeds are given to us, and these are the frequencies also given. How many were there in each of these types, and the total is also given to us. Now, can you say that the experiment is in agreement with the theory which predicts the proportion of frequencies 9 is to 3 is to 3 is to 1? This type of question if they give, also they will give here only the chi-square value also. Okay, for 3 degree of freedom. Okay, now after you have got to know that it is the chi-square test, what you have to do? First, observe the frequencies here. They have given 9 is to 3 is to 3 is to 1. Okay, so 9 plus 3 plus 3 plus 1 is 16. Now first frequency will be 9 by 16, this will be 3 by 16, this will be 3 by 16, this will be 1 by 16. Like that you have to calculate the frequency values and multiply it with the total value. Okay, so here we'll calculate these values and multiply with the total value. We'll get these values here. These values you keep. These are the calculated values. Okay, calculated values are these. Now we have the calculated values 313, 104, 104, 35, and these are the observed values 315, 101, 108, 32. Okay, so we have two values. These are the observed values which are given in the question. This is given in the question, and this one we calculated. Okay, so you'll write it in this fashion here, above each other. Now the total sum will be same in both of them. Now how do you calculate this value here, chi square value? OI minus EI square divided by EI for each of these terms. 315 minus 313 whole square divided by 313 plus 101 minus 104 whole square divided by 104. 108 minus 104 whole square divided by 104, 32 minus 35 whole square divided by 35. Like that you will do and calculate one value which you will get as 0.51 here. Now the DF value is 3 here. So v is equal to 4 minus 1, you have to just write here. Now if v is equal to 4 minus 1 is equal to 3, df is equal to v. Okay, v is equal to 3, we have to calculate chi square value. Okay, this also the table is table will be there. If that table is not there, they will give you in the question only what is the chi square value. For the chi square value of 0.05, 7.815 is given, so we'll consider 7.815, and the value we have got is 0.51. The value we have got is less than the value which they had expected, therefore we accept h naught. That's all. Okay, so this is the there are three types in chi-square test. The first type is directly they'll give you the frequencies, and using the basic formula of the mean and the squares we'll be calculating it. That's the first type. Second type is they will give you the formula and tell you to calculate in the form of Poisson distribution. Okay, Poisson distribution, you have to calculate the chi-square. Now how do you do that? Now see, this is the table given to us, and x values are given here, frequencies are also given here. Now for the Poisson distribution, first you have to calculate the sum of frequencies, that will be n 200. Now after you have got the n value, you have to find out the mean. Mean will be nothing but 0 into 122 plus 1 into 60 plus 2 into 15 plus 3 into 2 plus 4 into 1. Multiply all this and add up and divide by the summation of all the frequencies, so we'll get the mean value. So this is the mean value, 0.5. Now in Poisson distribution, lambda is equal to 0.5. Okay, that is nothing but the mean value. So probability will be equal to lambda raised to x e raised to minus lambda divided by x factorial. Now lambda value is 0.5, so substitute 0.5 here. After that, in Poisson distribution and theoretical frequencies calculated using n into p of x. After you calculate the p of x value, multiply it with the n value, which is 200. Now 200 into this term. Now in this term, I can multiply 200 into e power minus 0.5, because both are constant. This is constant, this is constant. If I multiply, I'll get 1 to 1.3 multiplied by this value. Now this value I have to calculate for all of them. Okay, I have the x value differing here, right? I have x value 0, x value 1, x2, x3, x4. So I have 4 types of values. I'll substitute the x values in this equation for the 5 x values which I have, and I'll calculate the answer here. Okay, for the 5 x values I'll substitute from 0 to 4. I'll get some answers here. That answers I will then put it in this table. Okay, the answers which I calculate, I'll put it here. The answers which I've got, I'll means the question which it is given, I'll put it here. Okay, now the last two values are added up here. Why? Because one of them is 0, we cannot take 0. So if there is a 0, we'll add up the last two. Okay, so 2 plus 1 is equal to 3, 3 plus 0 is equal to 3. Now what is 2 plus 1 and 3 plus 0? What I've written here, 3 and 0 I've got here values. The last two values, 3 and 0, which I calculated, and 2 plus 1, 2 plus 1 is nothing but in the question they are given, right? The x values 2 and 1, right? This is the 2 and this is the 1, the frequencies, last two frequencies that they have given in the question, and the values which I have calculated, 3 and 0, just add up them and put it here. Now the sum will be same here, 200 and 200. Now calculate this value, oi minus ei divided by ei whole square, same as previous one. After you have obtained this table, the procedure is same. After that, you'll get one answer. If it is less than the value which they are given in the question, which is 7.815, you'll accept the hypothesis. Okay, this was the second type, which is Poisson distribution. Third type which they can ask in the exam is the binomial distribution for the data. Now see, binomial distribution, they'll give you the x values, which is number of heads here, 0, 1, 2, 3, 4, frequency is given. Now x chi-square value is also given to us. All you have to do is the same steps will follow. This values are also same here. Just we'll try to solve it using binomial distribution. Find out the n value here, find out the mean value, same as previous question, and here we have to use np, because the binomial distribution we need np. What is np? Np is nothing but the mean value, which is 0.5. So p will be 0.5 by n. What is n? How many values are there in the n has 4 values, so we'll be taking it as 0.5 by 4. Okay, so here why we have taken the n value as 4 is because at the end we will be adding up these last two values, right? Because one of them will be 0 in this case, we have seen in the previous question, right? So that's why I have taken the n value here as 4, because finally in the table here we'll be having 4 values only. Okay, observed frequencies are the given one here, and see, only the 4 values will be having at the end. Okay, because one of them is 0 here. Now based on that, we have taken the value of n as 4. Now you'll get an answer here, which is the value of p. P is 0.15, so q will be equal to 1 minus 0.15, which is 0.875. Now observed frequencies are 122, 60, 15, 2 and 1. Okay, so these are the ones which are observed frequencies. Okay, these we have taken here. After that, the expected frequencies are calculated using n into p of x. What is p of x? In binomial distribution, the p of x value is given using this formula. Okay, all values we have here, p value and q value, substitute them, find out the answers and keep these ready, and substitute these values in this table, the expected and the observed values. After that, find out in the same way as we have done in the previous question. You will get an answer less than that given in the question, and that is the fitness is good because it is So this is how you calculate the binomial distribution question. The three types can come. First is the normal frequencies, second is the Poisson distribution, and the third one is the binomial distribution. Okay, moving on, we have the last topic, which is the F test, Fischer's test. Very simple. Two samples will be given to us, S1 S1 square, S2 square, or they'll give you the numbers here. Based on the numbers, you have to calculate these two values. After that, just divide them and make sure that the numerator should be greater. If S1 is greater than S2, divide S1 by S2. If S2 is greater than S1, divide S2 square by S1 square. Okay. So let's have a look at the question. Now see, the sample are 7 and 6 here. Okay, the numbers are given to us, so we have to use this formula to calculate S1 square and S2 square. 7 samples, 6 samples. Okay, now examine whether the samples have been drawn from the normal populations having the same variance. Now they have specifically mentioned F. Okay, they'll specifically mention if it is you have to use the F test. They'll give the value of F at 6,5, which is 4.95, and for 5,6 it is 4.391. Now for 6.5 and 5.6 both they have given. Let's see how to proceed with this one. Now calculate the mean value, add up all the numbers in the x which they have given, divide by 7, and for the y also calculate the mean in the same way. You'll get 31.285 and 28.166. Okay, just add up all these values, divided by 7, add up all these values, divided by 6. You'll get the x bar and y bar means. Okay, substitute these values here after calculating xi minus x bar. Here each term you have to subtract from the mean and square it. Okay, so mean we have got 31.285, right? So what you'll do, 31.285 minus 28 whole square, 31.85 minus 30 whole square, 31.85 minus 32 whole square. After finding out all the squares, add them up. Okay, like that you'll calculate the this value, this whole value. Okay, see, 28 minus 31.285 whole square plus 30 minus 31.285 whole square, and so on. Then divided by 6. How many samples were there? Minus 1, n minus 1. Okay, so 7 minus 1. Similarly, do for the S2 also. You'll get one answer here. Divide all these two answers. S2 is greater, so first, so divide S2 by S1. You'll get one answer here. Now, further, since DF is 6 and 5, okay, 6 and 5, first we had the 6 here, and here we have the 5. Okay, for S2 it will be 6 minus 1, so it will be 5. So we have to consider 6 and 5. Okay, so 6 and 5, the values they are given is 4.95. So the calculated value is less than the value which they are given in the question for 6.5. Therefore we accept the hypothesis. Okay, this all the questions will be similar in the type of F test. Okay, only one type is there. So that's all. If you found this video helpful, please do like and subscribe. That helps me make more videos like this. And thank you so much for watching. I'll see you in the next one.